Creating input-output graphs in Wireshark. Besides being incredibly useful, this is also a lot of fun. Let's begin. In this video, we're going to take a look at I/O graphs, input-output graphs, and as I look at this, that looks like a 10, which sounds like a binary joke of some type. In any event, our objectives in this nugget are pretty clear. We're first of all going to take a look at where is it that you would go to launch this I/O graph, and it's right off of the statistics menu. There's a drop down, we select I/O graph, and that's how we can launch an I/O graph. Regarding the X and Y axes, I guess it's an X axis and a Y axis, and together it'd be X and Y axes. In any event, to control those, we have our options over here. And by default, it's going to be in seconds. So from the beginning of the trace at the 0 mark, and then it shows the time has passed as that capture continued. The interval is 1 second by default. And again, this is for the X axis right here. And for the Y axis, going up and down vertically, we can have it show us packets per tick. In this case, every tick is 1 second, so packets per second. Or we can change that to bytes per tick. In this case, bytes per second, or even bits per tick. So if you wanted to see, for example, what is the throughput for some specific protocol or some IP address at any given moment, this would be a great way to go ahead and visually see that information. We could change this into bits per second, and then this y-axis would represent the quantity of bits. We also get the opportunity to choose the type of graph that we're going to create. So we have the option of a line. This red line right here is an example of a line graph. We have the F bar, which is in green. That's these little stubby guys down here, the little green ones. We have dot, and in this case blue. We have these blue dots indicating the data points on the graph. And there's also another one called impulse, which is like F bar, except they're really skinny lines. Now here's what's important to know. When we launch statistics and we go to I/O graph, by default it's going to have graph number 1. These are all buttons. It's going to be selected and it's going to show us all the traffic. And it will be a black line graph showing us that traffic. If we don't want to see a specific graph, we can click on this button, turn it off, and then if we want it back on, we can click it to turn it back on. It's also important to know if this gets really busy and some of the graphs are blocking out other graphs, it's the ones on top that are going to win. So when in doubt, you can verify if you're covering up any information simply by turning these on or off temporarily, just to see if there's anything hiding behind it that you want to see. And if there is, you can change the style so that it won't block it. For example, this F bar right here for DNS, that's not blocking anything behind it because it's so small. However, if that was the majority of our traffic, it could very well block the information behind it. So we have the opportunity to modify the style of graph, not just for, aesthetics, but also for the benefit of being able to see all the data in our graph. If you've noticed, more than half of our videos in Wireshark involved in some way a display filter. And in I/O graphs, that's no exception. We're going to use display filter syntax once again to identify what we want the different points to be on our graph. So pretty much anything that we have in a display filter will work here. And if we have filters that we have saved, we can click on this button to go ahead and call upon a pre-saved or a predefined filter instead of having to write it out. So that, my friend, are the basics of I/O graphs. The best way to learn graphs, I/O graphs, inside of Wireshark is to practice them. I have the capture file that I'm using in this video available for you in the Nugget Lab area. If you want to grab that, you can follow along right with me as we build and manipulate a few I/O graphs. So here's our capture file. It's called iographs.pcap, and let's go ahead and create an I/O graph. To do that, we're going to go to Statistics, and then from the drop-down menu here, we're simply going to select I/O graph. Now when this comes up, here's the defaults. We have graph number 1, so we have a black line, and the style is line, and this is showing us all the traffic in that capture. That's the starting point, and this capture looks like it was less than 90 seconds in length, the entire capture. If we want to view the time instead of seconds from the beginning of the capture, instead we want to look at the time of day, we can click this little checkbox right here, and it will show us the time of day instead. But the default is to show us the seconds from the beginning of the capture. Also, the default tick interval for the x-axis going left to right is 1 second. And that'll be graphically represented as 5 pixels per tick, or in this case, 5 pixels per second. And for this y-axis right here, it's going to be packets per tick, or in this case, packets per second. If we wanted to see throughput, for example, we could change this. Instead of saying packets per tick, we could go down here and say bits per tick. So with this set to bits per tick, or bits per second, because our tick is equivalent to a second, we can know that our traffic, this is 1 million, so that's 1 million bits per second, or 1 megabit per second. So this represents that out of all the traffic that's currently being displayed, we have no filters in place, all the traffic is just going just a little bit above 1 megabit per second at its highest points, which would be here, 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 and here. And maybe really close there too. So we can choose to use whatever we want per tick. I'm going to go ahead and set it back to packets per tick. The important part is that we know we can change this to whatever we want it to be for this y-axis right here. See how this button right here is highlighted already? Because it's currently active. If you don't want to see graph number 1, you can go ahead and simply unselect it. So if you want graph 2 in red, boom, there you go. So all that's doing is showing us all the traffic with no filters in place. So let's go ahead and put some filters in place. And let's start with red, because it's more colorful. Let's say, for example, we want to search for any traffic that is DNS. Now, this syntax we're going to use right here is the exact same syntax we would use in a display filter. So we can leverage those skills that we already have. And let's say I want to see all the traffic if it's DNS. So we'll put in DNS, press enter, and that's going to show us our DNS traffic. What just happened is the scale changed right here. Because DNS is our only protocol that we're representing at the moment, it changed the scale from 0 to 20, and we have our unit set to packets. So this represents about 10 packets right there, and perhaps 18 packets right there, approximately right there. And it's also showing us, based on the timestamps in that packet capture from the beginning, where that volume happened, which is pretty cool. So we might think, wow, DNS, that's quite a bit of traffic, until we compare it to something else. So let's compare that against, for example, TCP port, and let's say 80. Now we could, I suppose, specify right here just protocol HTTP, but we might miss a few packets. For example, there might be some three-way handshakes and some other TCP activity that aren't defined directly by the application layer of HTTP, and we don't want to miss those. So if we include port 80 as either the source or destination, that'll help ensure that we're identifying all traffic that's either coming to or from the well-known port of 80. So to make that active, we're going to click on graph 3 to make it active. It's going to repaint. And now in comparison, again, we're still doing the packets per second. So here's our web-based traffic in green, and down here we have the DNS traffic in red, based on the colors that are associated with graphs 2 and 3. Now we have a few options left here. We have 3 different graphs that we can still add. So let's go ahead and say, you know what? I see a host up here. I see this device at 172.16.20.2. He's on VLAN 20 based on the subnet address. I wonder how much traffic he personally is generating. Well, we can just add that. We can say I want to add the IP address of 172.16.20.2 and then click on graph 4 to bring it in. So it appears that most of that port 80 traffic that we saw is involving this specific host right there. So see how it's not really easy to read like that because they're right next to each other? What we can do is we could change the style of that graph. We could say, instead of using line for this specific host, let's go ahead and make him dots like that. So the blue dots represent the traffic specifically to or from 172.16.20.2, which leads us to the other question: what is this all about? Whose traffic is that right there? So all this information was captured on a trunk and involved VLAN 10 and VLAN 20. If we wanted to see VLAN 10's traffic, we could go ahead and say this: IP address 172.16.10, and check this out. I'm going to put .0/24, and it knows exactly what I mean. It says, okay, the first 24 bits have to match 172.16.10, and if it does, that'll match this display filter. So let's go ahead and add that one, which looks like it's kind of like a pinkish color. We'll click on graph 5 to bring it up, and there it is right there. So if we want to change that and make that, for example, impulse bars, we can. And now those pink bars represent any traffic that's involving any of the addresses from the 10 subnet, which is 172.16.10 IP address space. So because we can pull from virtually anything inside of that capture file, and because this was all pulled off of a trunk, so we have these 802.1q headers right here. Let's try one more field. We have one more we can add. So let's specify yet another way to identify traffic. Let's say VLAN ID equals, and let's go ahead and say 10. Now what this is pretty much another way of saying this one. So this is any traffic on the 162.16.10 network as far as to or from. This is saying any 802.1q tags that include the label of 10. So as far as that one, which is going to be in black, let's also go ahead and make that dots because I'm expecting it to be equal to the pink impulse lines. And we'll turn that on. And there we have it. Now that's pretty cool too, because previously I wouldn't have even noticed these guys right down here. But now I can see them as some VLAN 10 traffic that was happening. Although very, like one packet there, one packet there, one packet there. So the cool thing is virtually anything that you can do in a display filter, you can do right here as well to cause the graphs to show up as you want them to. Now, what is better than making a graph? Well, what's better than making a graph is sharing that graph with somebody else or putting it into a report. To do that, we're simply going to go ahead and click on Save. And then we can save this as a PNG file or a JPEG. There's several options on the file type down here. And we can save it to the folder that we want. So I'm going to save this to the Nugget Lab files. And I'd like to save it as a JPEG. And I'm going to go ahead and call this example graph.jpg. And it's saved. Now, besides the fact that this gives us a really cool tool to visually see the I/O based on protocols or IP addresses or virtually anything else that we want to pull out of our capture, it's also a boatload of fun to visually create stuff. So there's also the fun factor as well in creating graphs. In this video, you and I have taken a look at I/O graphs. We identified, first of all, where we would go to launch one. That's under Statistics and selecting I/O graph. We also identified that by default, graph number 1, which is a line graph, black, by default, line graph is going to be the only graph that shows up, but we can use these buttons to enable additional graphs and use display filter syntax to control what each of those graphs is going to represent. I've included in the Nugget Lab area the capture file I used in this demonstration. If you'd like to play with that one and follow the exact steps I did to kind of warm up to the idea, that would be great. The more you practice right now with techniques such as I/O graphs, the better prepared you will be to apply those same skills to the production network traffic. I've had a great time. I'm glad you've joined me. I hope this has been informative for you, and I'd like to thank you for viewing.